So now let's see question number 9. And question number 9 says that the color appears on the thin soap film as on a soap bubble due to the phenomena of. So it's basically interference, not dispersion, right? Why it is interference? That people when see the light from inside the bubble when comes out, not the entire light get refracted. There is some light which get reflected back inside the bubble, and this process continues. And because of there are two lights, one is the reflected and the light which is getting incident on the surface, they both interfere with each other, and then our eyes experiences this interference pattern, which is because of the white light. And whenever the interference pattern is formed because of the white light, it forms the band of different colors, right? So the correct answer for question number 9 for this case is your interference pattern, not dispersion, right? So now let's come to question number 10. Question number 10 says that on introducing a thin film in the path of one of the two interfering beams, the central fringe will shift by one fringe width. If mu is equals to 1.5, then the thickness of the film is. So the shift is being given by the formula mu minus 1 into T capital D by D, right? Capital D by D. And here they say that the shift is equals to one fringe width, which is given by lambda D by D, right? So this lambda D by D cancels out with this D by D. This is T, right? This is T. So we are left with is your mu minus 1 into T is equals to lambda, right? So what they are asking is the wavelength. Refractive index has been given to us as 1.5 and thickness has been given to us as, then the thickness of the film is, alright, they are asking thickness of the film. So thickness of the film is to be given in the terms of lambda. So since we have your mu as 1.5, we will get 0.5 T is equals to lambda. So your T will be equals to lambda upon 0.5, which is equals to your 2 lambda. So thickness of the film will be equals to 2 times of lambda, which is your option 3. So the correct answer for question number 10 is option 3, right? Now let's come to question number 11. Question number 11. Now question number 11 says a slit 5 centimeter wide is irradiated normally with microwave of wavelength 1 centimeter. Then the angular spread of the central maxima on either side of the incident light is nearly, right? So in the question they have given us the width of the slit is 5 centimeter, right? The wavelength of light is being given to us as 1 centimeter, that is 10 millimeters, and we know that the angular spread is been given as theta is equals to lambda upon D. So lambda upon D, putting lambda upon D, we get lambda upon D, we get theta is equals to your 1 by 5 radian. Putting the values we get it's as theta is equals to 1.5 radian. So simply what we have used over here is that angular spread theta is equals to lambda upon small d. Lambda and small d both are being given to us question. So therefore we get theta is equals to 1 upon 5 radian. So which is your option 1. So correct answer for question number 11 is option 1, right? Now coming to question number 12. Question number 12 says that a beam of light strikes a piece of glass at an angle of incidence 60 degrees and the reflected beam is completely plane polarized. The refractive index of the glass is. So if the light ray getting incident at 60 degree, it is getting completely plane polarized. It means it's an angle of it's the case of Brahmastra's angle. So your I P is equals to tan inverse of mu. They are asking us to calculate mu, that is the refractive index. So refractive index will be equals to tan IP, and IP over here in the question is given as 60 degree. So tan 60 is root 3. So our refractive index mu will be equals to root 3, right? So the correct answer for question number 12 is root 3, that is option 2. So the correct answer for question number 12 is option 2, right? Now let's come to question number 13. Question number 13 says that in the front of us diffraction at a single slit of width d with incident light of wavelength 5500 angstrom, the first minima is observed at angle of 30 degree. The first secondary maxima is observed at an angle equal to, right? So in the question, the slit width is given as d, wavelength is given as 5.5 into 10 to the power of minus 7 meter, that is 5500 angstrom. When converted into meter, it will give you 5.5 in 10 to the power of minus 7 meter. 1 angstrom is equal to 10 to the power of minus 10 meter, right? Angle theta has been given as 30 degree. Now the first secondary maxima using formula d sine theta n is equals to lambda. Putting the values, we get d is equals to 11 into 10 to the power of minus 7 meters. Now first, for the first secondary maxima, we get d sine theta is equals to 3 lambda by 2. Now putting the values, we get your theta is equals to sine inverse 3 by 4. So at an angle of sine inverse 3 by 4 will be your first secondary maxima, right? First secondary maxima. So the correct answer for your question number 13 is option 3, that is sine inverse 3 by 4, right? So using the data, that is your angle for the first secondary minima, wavelength and the slit width, we calculate slit width, that is d. Using the formula d sine theta is equals to lambda, we calculate d, where theta has been given to us and lambda has been given to us. And using this d, we use using this d in the formula for the first secondary maxima. Here we get the value of your angle theta. Now coming to question number 14. Question number 14. Yeah, question number 14 says that the separation between the point source of light and the screen is increased by 0.5%. The intensity of the light on the screen will see, the intensity is inversely proportional to r square. The intensity of the light follows the inverse square law, right? Where r is the angular separation between the point source of the light and screen. Therefore, your change in intensity, percentage change in intensity, that is delta I upon I into 100 is equals to 2 delta r upon r, where delta r is the change in the position of the screen with respect to the source, right, upon r. So if the percentage change in the separation between the screen is 0.5%, therefore the percentage change in the intensity will be equals to 1%, right? So here the two things which we have used is, here is we have used the error analysis, and the relation which we have used here is that intensity follows the inverse square law, that is, it is inversely proportional to the square of the distance between the light and the light source and the screen, right? So let's come to question number 15 then. The question number 15 says, that for best contrast between maxima and minima in the interference pattern in Young's double slit experiment, the intensity of light wave emerging out of the two slits should be equal, right? Now the intensity of interference pattern is proportional to the square of the amplitude of the resultant wave. Yes, this is also correct. See, both the statements are correct, but reason is not the correct explanation for the assertion, right? So according to this, the correct answer will be option 2, right? So what they say in the question is that for the best interference pattern, the amplitude of the two waves emerging out should be equal, right? And in the reason, the reason which they give is that in the intensity of the interference pattern is proportional to the square of the amplitude of the resultant wave. So this is not the correct explanation for the assertion. The intensity is proportional to square of the amplitude. That is true, but this is not the correct explanation for the assertion. So the correct answer for question number 15 is option 2. Right? So the assertion says that the best contrast between maxima and minima in the interference pattern in Young's double slit experiment, the intensity of the light wave emerging out of the two slits should be equal. Right? Yeah, this is the, so yeah, correct answer is option 2. Now let's come to question number 16. Question number 16 says that what will be the angular width of the central maxima in Fraunhofer's diffraction when the light of wavelength of 5000 angstrom is used and the slit width is 10 into 10 to the power of minus 5, right? So here we will be using the formula, that is the angular width is equals to 2 times of lambda upon d, right? So the formula for value for lambda has been given to us, lambda for value for small d is also been given to us. Lambda is given as 5000 angstrom, which can be written as your 2 into 5 into 10 to the power of minus 5, right? Upon d been given to us is as your minus 5 in centimeter, right? And this has been given as 10 into 10 to the power of minus 5 centimeter. Solving this, we will get your theta is equals to 1 radian. So the correct answer for question number 16 is option 3, that is 1 radian. Now let's come to question number 17. Question number 17 says that the two polarizing sheets are placed with their plane parallel so that intensity of the transmitted light is maximum. The angle through which the either sheet must be turned so that light intensity drops to half of its maximum value, that is I should be equals to I 1 by 2. It should be half of its maximum value, right? So your in according to the Morse law, the intensity of the light emerging will be equals to I2 is equals to I naught into cos square theta. So cos square theta is equals to I upon I naught, and which they want it to be half, right? So which they want it to be half. So cos theta will be equals to plus minus 1 by root 2. So angle should be either 45 degree or should be equals to 35 degree, right? So the correct answer is option 4. Option 4. So directly using the Morse law, that is I2 is equals to I naught into cos square theta, because they are saying that the what should be the angular heat, so that the light intensity drops to half of the maximum intensity. So maximum intensity is I naught, which is initial intensity, and output is your I2. So according to Morse law, the relation becomes that I2 is equals to I naught into cos square theta, and they say that I2 should be equals to half of I naught. So if we put I2 is equals to half I naught upon 2 and solve this, we'll get theta is equals to plus minus 1 by root 2, and plus minus 1 by root 2, theta will be equals to either 40 degree or 45 degree. So the correct answer is your option 4 for question number 17. Coming to question number 18. Question number 18 says that the velocity of the light is 3 into 10 to the power of 8 meter per second, and in water it is 2.25 into 10 to the power of 8 meter per second. The polarization angle for water interference will be, so polarization angle IP will be equals to tan inverse refractive index of water with respect to air, and refractive index of water with respect to air will be equals to, that is mu will be equals to C upon velocity of light in water. C, putting the value C as 3 into 10 to the power of 8 and V is equals to 2.25 into 10 to the power of 8, we will get refractive index as 4 by 3. So IP will be equals to tan inverse 4 by 3, right? So tan inverse 4 by 3 will be equals to your tan inverse 4 by 3 will give you your angle as 53 degrees, right? So the correct answer for question number 18 is your option 3. How to find that it is equals to 53 degree? See, this triangle, a right angle triangle, if we have this as 4, we have this as 3, and we have this as 5, then we will have this as 5. For this case, this angle is equals to 37 degrees and this angle is equals to 53 degree. Yes, this is a known triangle. So here we say, it says that tan 4 by 3. Tan 4 by 3 means the perpendicular is 4. So 4 by 3, that is perpendicular is 4. So the angle opposite to it is 53 degrees. So tan 53 is equals to 4 by 3. So the angle is 53 degrees. And the formula which we have used is the same formula, that is IP is equals to tan inverse mu. That is angle of polarization is equals to tan inverse mu, that is the refractive index of the medium, right? Now let's come to question number 19. Question number 19 says, in the following modified setup of Young's double slit experiment, the number of minima formed in the screen is. Alright. So here we know that the constructive for the constructive interference, the path difference is equals to delta x is equals to n lambda, right? Now if the distance between the screen and the slit is much greater than d, then the delta x is equals to d sine theta, right? So from this first and this second, solving this will get n lambda is equals to d sine theta, and n is equals to d sine theta upon lambda, right? For maximum value of n, that is for the maximum value of n, that is for the maximum number of maxima, we will have to take the maximum value of sine theta. So maximum value of sine theta is 1, so we get n is equals to d by lambda. So n is equals to d by lambda, that is 2.5 lambda upon lambda, which is equals to 2.5. Hence the number of minima formed is equals to 2n plus 1, so it will be equals to 6, right? So the correct answer for the question number 19 is option 2. Correct answer is option 2, right? Here we have used two formulae, that is delta x is equals to n lambda, and your delta x is also equals to d sine theta. Equating both the values of delta x, we get n lambda is equals to d sine theta. Then from here we get n is equals to d sine theta upon lambda. All the values have been given in the question. Putting these values, we get n is equals to 2.5, and for minima, the number of minima is given by 2n plus 1, right? So putting the n is equals to 2.5, we get your number of minima is equals to 6. So the correct answer for this question is option 2. Now let's come to question number 20. Question number 20 says that a plane wave passes through a convex lens. The geometrical shape of the wave front that emerges is. See, when parallel beam of light passes through a convex lens, they converge at a point, and when they converge at a point, it seems, if you see from this direction, it seems that this is a point source and the light is getting emerging out of it, right? And if this appears to be a point source, then the wavefront for this should be a spherical wavefront. Now if we look from this side, that if a plane wavefront is incident on a convex lens, the emergent wavefront will be what? Spherical in shape, right? So here what they have given is your diverging spherical or converging spherical. So it will be converging spherical. So the correct answer for this question is option 3. Why converging spherical? Because the light rays are converging at a point. So definitely the wavefront will also be of converging nature. Now coming to question number 21. Question number 21 says that if two waves represented by y1 is equals to 4 cos omega t and y2 is equals to 4 cos omega t plus 2 pi by 3 interference at a point, the amplitude of the resulting wave is. So here in this, the two waves have the same amplitudes, that is a1 is equals to a2, right? And the phase difference is equals to 2 pi by 3. So the resultant amplitude, the value of resultant amplitude has been given by the formula. Your A is equals to under root of A1 square plus A2 square plus 2A1 A2 cos phi, right? So because A1 and A2 are equal, when we put the value here and solve it using cos 2 pi by 3, that is cos 2 pi by 3 is equals to minus 1 by 2, right? Putting all this value in this formula, we get your A is equals to root 16, which is equals to 4, right? So the amplitude of the resultant wave will be equals to a 4 units. So the correct answer is option 3. So the formula here we have used is the amplitude of the resultant wave is equals to your under root of A1 square plus A2 square plus A1 A2 2A1 A2 into your cos phi, where A1 A2 are the two amplitudes of the two wave and phi is the phase difference between them. So here in this question A1 and A2 both are 4 and phi is equals to 2 pi by 3. Putting these values and calculating, we get resultant amplitude as 4 units, right? Now let's come to question number 22. Question number 22. Question number 22 says that in Young double slit experiment, separation D and the distance of the screen from slits is capital D. First dark fringe is formed in front of one of the slit. Then wavelength of the light used will be. So if first dark fringe is formed at your first slit, it means that the position of the first dark fringe is equals to your d by 2, and position of dark fringe is been given by the formula y is equals to 2n minus 1 into lambda d by 2d. That is your position of the slit, position of the first dark fringe is given as 2n minus 1 into lambda by 2 into capital D by D. And according to this question, they say that this position is equals to in front of one of the slit. So the distance of one of the slit from the center maxima is D by 2. So now solving this, we get your lambda is equals to, when we solve this and we get, see here 2 will cancel out with this 2 and we get 2n minus 1 into lambda d is equals to d square. So your, because it's first dark fringe, so putting n is equals to 1, we get this turns out to be 1. So what we are left with is your lambda is equals to d square upon capital D. So they are asking us the wavelength of the light used. So wavelength of the light used, lambda will be equals to d square upon capital D. So do we have this in option? Yes, we have this in option 4. So the correct answer is option number 4, right? So again, now let's see question number 23. Question number 23 says that unpolarized light of intensity X is incident on a polarizing sheet. Intensity of the light which does not get transmitted is. See, whenever a light has been passed through a polarizing sheet, the output intensity is always half of the initial intensity, right? So therefore, if half is being transmitted, half is being not transmitted. So if the intensity was initially X, so the transmitted intensity will be X by 2 and not transmitted intensity will also be equals to X by 2. So the correct answer for this is option 2. Now let's come to question number 24. Question number 24 says that a star which is emitting a radiation of wavelength 5000 angstrom is approaching the earth with a velocity of 1.5 into 10 to the power of 5 meter per second. The change in the wavelength of the radiation as received on the earth is, right? Now for this we will use the formula, that is the new wavelength lambda dash upon lambda is equals to 1 minus v by c. This is the formula which we will be using. What we need to calculate is lambda dash. In the question they have given us lambda as 5000 angstrom, right? Speed of light is being given to this value of v is being given to us as your 1.5 into 10 to the power of 5. This is the speed of the light which it is, sorry, speed of the star with which it is approaching the earth, and c we know as 3 to 10 to the power of 8. Putting these values we get lambda dash is equals to, your lambda dash is equals to 2.5 angstrom, right? Putting the values here, putting the values here, we get lambda dash is equals to 2.5 angstrom. So the correct answer for question number 24 is option 4, that is 2.5 angstrom, right? Now let's come to question number 25. Question number 25 says that in a Young's double slit experiment, if the distance between the slit is halved and the distance between the slit and the screen is doubled, right? The fringe width becomes 4 times. Why 4 times? Because beta is equals to lambda capital D upon small d, right? Now they are saying that the distance between the slits is half. That is, this is being divided by 2, and the distance between the slit and the screen is being made double, so this is multiplied by 2. So this 2 will go up and it will become 4 times. So new fringe width will be lambda beta dash will be equals to 4 times of lambda d by d. So the correct answer will be your 4 times. So the correct answer for question number 25 is option 3, right? Now let's come to question number 26. Question number 26 says that if two waves each of intensity I naught have the same frequencies but differing by a constant phase 60 degree, superimposing at a certain point in space, then the intensity of the resultant wave is, again you can use the same formula, intensity I, resultant intensity I is equals to I1 plus I2 plus 2 I1 I2 whole root into cos phi, right? So here I1 and I2 are same, so we write it as I0 plus I0 plus 2 root I0 square into cos 60, right? Solving this we will get I is equals to 3 times of I0, right? So the correct answer for this question will be equals to 3 I0, which is option 2. So basically the formula which we have used here is I is equals to I1 plus I2 plus 2 under root of I1 I2 into cos phi. This is the formula for the resultant intensity of the, if the intensity of the two light rays are being given to us and the phase difference between them has been given to us, right? So the correct answer for question number 26 is option 2, that is 3 I0. Now let's come to question number 27. Question number 27 says that, question number 27 says that in an interference experiment, monochromatic light is replaced by a white light. We will see uniform illumination on the screen, no. Uniform darkness on the screen, no. Equal space white and dark, no. A few colored bands and then uniform illumination, right? The correct answer is option number 4, right? Why? Because option number 4? Because when white light is used for interference pattern, there the white light is comprising of different color light which have their different wavelength, and because the position of the bright and the dark fringe is dependent on lambda, right? They are dependent on lambda. Therefore, for different wavelength of light, different fringes and different fringe width will be obtained. But at center there will be a central maxima which will be of white color. This is the case of interference using a white light instead of monochromatic light. So in white light there is a bright white central maxima, but on both the sides of the central maxima we have bands of different colors forming maxima and minima. Therefore the correct answer for question number 27 is option 4. Now let's come to question number 28. Question number 28 says that a beam of light is incident on the glass plane at an angle of incidence at 60 degree. Now the reflected ray is polarized. If a light ray incident at an angle of 37 degree, the incident refraction will be, right? So what they say is that if, see here in the figure, the light ray is getting incident at an angle of 60 degrees. Now when it get reflected, this angle will be equals to 60 degree, right? This will be equals to 60 degree, and because it is getting polarized, then the angle between the reflected light ray and the refracted light ray will be equals to 90 degree. Now if this is 90 degree, this whole angle is 180 degree, this is 90, this is 60, so this is 150, and if this is 150, this will be equals to 30, right? So now from here we can say that the incidence angle is equals to 60 degree, and whereas refraction, angle of refraction is equals to 30 degree. So from here we can find the refractive index of the medium, that is mu is equals to sine I, that is sine 60 upon sine r, which is sine 30, right? So this will be equals to your root 3. So refractive index is equals to root 3. Now because refractive index is equals to root 3, what they are asking is the angle of, if the light ray is incident at an angle of 37 degree, the angle of refraction will be, so mu, using Snell's law again, mu is equals to sine I upon sine r. So this implies that root 3 is equals to sine 37 upon sine r, right? Sine 37 upon sine r. So from here we'll get your sine r is equals to sine 37 upon root 3. Now sine 37 again using the triangle, this triangle, that is, this is, if this is equals to 4, this is equals to 3, then this is equals to 5, and in this angle is 37 degrees. Now if this is 37 degrees, then sine of this will be equals to 3 by 5. So sine 37 will be equals to 3 by 5, so we can write it as 3 by 5 root 3, right? So it will become your sine r, right, I'm writing here, it will become sine r is equals to your root 3 by 5. So r is equals to sine inverse of root 3 by 5, right? Sine inverse of root 3 by 5. Do we have this? Yes, we have this in option 2. So the correct answer for question number 28 is option 2. Question number 28 is option 2, right? Now let's see question number 29. Question number 29 says that the two coherent monochromatic lights, waves of amplitude 3a and 2a interfere at a point on the screen having a phase difference of pi by 3. The resultant intensity of at that point will be proportional to. Okay. So again we are using the formula. What formula? That is A is equals to under root of A1 square plus A2 square plus 2A1 A2 into cos phi, right? 2 times of A1 A2 cos phi. Here A1 is given as 3a, A2 is given as 4a, and phi is been given as pi by 3. From here, putting this value, we get your A square, that is the amplitude of resultant wave, is equals to 19A square, right? So A square can be written as intensity, or the intensity of resultant wave can be written as I is equals to A square. So I will be proportional to 19A square, right? So the correct answer for this question is your option 3, that is 19A square. So basically we are using the formula, the amplitude, resultant amplitude is equals to A is equals to under root of A1 square plus A2 square plus 2 A1 A2 cos phi, right? Now let's come to question number 30. Question number 30 says that if critical angle of the transparent crystal, that is theta c, is equals to 37 degrees, then its polarizing angle will be. So if theta c is been given to us, we can calculate your refracting angle, refractive index, because sine theta c is equals to 1 by mu. So sine theta c means sine 37, right? Sine 37, we just saw that sine 37 is equals to your sine 37 is equals to 3 by 5, right? So sine 37 is equals to 3 by 5 is equals to 3 by 5, and this is equals to 1 by mu. So mu is equals to 5 by 3. Now if mu is equals to 5 by 3, then polarizing angle IP will be equals to tan inverse mu. So IP will be equals to tan inverse 5 by 3, right? So tan inverse 5 by 3 is the correct answer. The correct answer for question number 30 is option 1. Now let's come to question number 31. Question number 31 says that choose the correct statement among the following. It says that the locus of all those particles which are vibrating in the same phase at any instant is called the wavefront, right? This is correct. The speed with which the wavefront move outwards from the source is called the speed of wave. This is also correct. The shape of the wavefront due to a point, so is a spherical shape. This is also correct. So the correct answer for this question number 31 is option number 4. Okay. So because the statement 1, statement 2 are the Huygens, yes, Huygens principle. So the option 1 and option 2 are correct. Option 3 is also correct. So the correct answer for question number 31 is option 4. All the three statements are correct, right? So the correct answer is 30 for 31 is option 4. Now coming to question number 32. Question number 32 says that if we have two coherent sources S1 and S2 vibrating in equal phase, alright, then for an arbitrary point P where the path difference is n lambda, will have a constructive interference, right? Because if delta x is equals to n lambda, we will have constructive interference. So the correct answer for this is option 1. We will not have destructive interference. Resultant intensity of 4I, where I naught represent the intensity produced by each one of the individual sources. Resultant intensity of I naught. If two coherent sources S1 and S2 vibrate into equal, yes, they are saying coherent sources, no? But the amplitude is not been given to us, right? Amplitude, because amplitude is not been given to us, we cannot say this. So option 4 is not correct. Option 1 is correct. That is, they form a constructive interference. If it was being said that S1 and S2 has the same intensity I1, then this would have been correct. That the resultant intensity of 4I0, where I0 represents the intensity produced by each one of the individual sources. So this has not been given in the question. If it was being given in the question that S1 and S2 have the same intensities I0, then this option would have been correct, right? Let's coming to question number 33. Question number 33. Question number 33 says in the assertion, it says that in interference and diffraction, light energy is redistributed, right? True. Now there is no loss of energy in interference and diffraction pattern. This is also true, but this is not the explanation for the yeah. There is no loss of energy in interference pattern because it has been redistributed. Yeah, both are complementary to each other. Yes. So the correct answer is option number 1, right? Because in interference pattern and in diffraction pattern there is no loss in energy, although there is a dark fringe and then a bright fringe. This is because the energy gets distributed, it gets redistributed, right? So the correct answer is option 1, that both assertion and reason true, and the correct explanation for reason is correct explanation for your assertion, right? So the correct answer is option 1. Now coming to question number 34. Question number 34 says that a plane polarized light with intensity I naught is incident on a polaroid with an electric field vector making an angle of 45 degree with the transmission axis of the polaroid. The intensity of the transmitted light is, again using the Morse law, that is your output intensity will be equals to input intensity I naught into cos square theta, right? Theta here is 45 degrees and initial intensity is I naught. Putting this, we will get I is equals to I naught upon 2, right? Because cos 45 is equals to 1 by root 2, so its square will be equals to 1 by 2, so I will be equals to I naught upon 2. So the correct answer for question number 34 is option 2, that is I naught upon 2. Now coming to question number 35. Question number 35 says that in a Young's double slit experiment, sheet of refractive index mu 1.5 and thickness 1.5 micrometer is introduced in the path of one of the wave. The intensity at position of central maxima is, they're asking intensity. Alright, so what they have given to us is that refractive index is equals to 1.5 and your thickness is equals to 1.5 micrometer. So shift delta x will be equals to your refractive index minus 1 into thickness t, right? And your phase difference phi will be equals to 2 pi by lambda into delta x. So in place of this delta x, we can put this value. So we will get phi, see the calculation has been done over here, phi delta phi is equals to 2 pi by lambda into delta x, and delta x will be equals to 2 pi by lambda into mu minus 1 into t, right? So what we will get, we will get delta phi is equals to delta phi, that is phase difference, will be equals to 2 pi by lambda into delta x. Delta x is equals to mu minus 1 into t, right? We have the value of mu, we have the value of t. Putting this value, we will get delta phi is equals to 3 pi, right? Now the resultant intensity I, because the intensity is I naught, I naught is the intensity, so I will be equals to your 2 times of I naught, right? That is I1 plus I2 plus 2 times of under root of I1 plus under root of I1 I2. It will result in 2 I naught into cos phi, that is cos 3 pi, and cos 3 pi is equals to minus 1, so it will be equals to 2 I naught minus 2 I naught, so I will be equals to 0, right? So the correct answer is option 4, right? Again just for your understanding, I use the formula I is equals to I1 plus I2 plus 2 under root I1 I2 cos phi. phi we calculated as root 3. I1 and I2 is equals to I naught. So this will result in 2 I naught, the sum of these two, plus 2 I naught into I naught is I naught square, and root of I naught square is equals to I naught into cos phi is 3 pi, right? 3 pi, and cos 3 pi is minus 1. So this will become 0. So the resultant intensity is equals to 0 here, right? So the correct answer for question number 35 is option 4. Okay, now let's come to question number 36. The question number 36 says that the correct curve between the fringe width and the distance between the slits. So fringe width beta is equals to lambda d by d. It means beta is inversely proportional to small d, and the graph for inverse proportion is your option 2. So the correct answer for question number 36 is option 2, right? This is the graph which represents the inverse proportion. Now question number 37. Question number 37 says that consider a Young's double slit experiment that has different slit widths. As a result, the amplitude of the waves from the two slits are A and 2A respectively. If I naught be the maximum intensity, of the interference pattern, the intensity of the pattern at a point where phase difference between the wave is phi is. Now see, if A1 is equals to A and A2 is equals to 2A, the resultant intensity I will be given as A1 square plus A2 square plus 2A1 A2 cos phi, and this I maximum will be maximum as this cos phi is equals to, for cos phi is equals to 1, that is phase difference is equals to 0. So this will have I maximum is I1 square A1 square plus A2 square plus 2A1 A2, right? So this is I maximum. I maximum, I'm putting the values and solving it, we get I maximum is equals to 9A square, and this 9A square they are saying that I maximum is equals to I naught. So it means that I naught is equals to 9A square, right? This is the maximum amplitude. That is, if the amplitudes are your A and 2A, that is A and 2A, then the maximum intensity or the maximum or the resultant magnitude for the maxima will be equals to 9A square. And if this is the maximum intensity, then they are asking us to take this maximum intensity as I naught. So we write I naught is equals to 9A square, right? It means A square is equals to I naught upon 9. Now what they are asking is that if I naught be the maximum intensity of the interference pattern, that intensity of the pattern at a point where the phase differences between them is phi. So again in the same formula, this formula, that is I is equals to A1 square plus A2 square plus this I, if this I is creating confusion, this I is nothing but A square. So we had the formula A square is equals to A1 square plus A2 square plus 2A1 A2 cos phi. So instead of writing A square, I am writing it as I, right? Now for at any point, intensity I will be equals to A1 square plus A2 square, putting the values A1 square plus A2 square plus 2A1 A2 cos phi. Solving this, when we take A1 square common outside, we'll get I is equals to I naught by 9 into 5 plus 4 cos phi, right? We have to simply solve this, and then we get I is equals to I naught by 9 into 5 plus 4 cos phi, and this we have in your option I naught by 9 5 plus 4, option 3, right? So the correct answer for question number 37 is option 3. So again the basic formula which we have used here is your, that is resultant amplitude A square is equals to A1 square plus A2 square plus 2A1 A2 cos phi. Now let's come to question number 38. Question number 38 says that a central fringe of a interference pattern produced by a light of wavelength 6000 angstrom is found to be shifted by a position of fourth bright fringe. After a glass plate of refractive index 1.5 is introduced in front of one slit in the Young's experiment, the thickness of the glass plate is. So the shift over here is delta x is equals to, is been given as, your formula is mu minus 1 into t, and according to the question this shift delta x is being given as the position of the fourth bright fringe. The position of the fourth bright fringe is equals to 4 lambda d by d, right? So equating these two equations, we get your, I'm writing here, is if we get 4 lambda d by d is equals to mu minus 1 into t, right? Mu minus 1 into t, capital D by D, right? Here we have capital D by D. Now this capital D by D cancels out, right? So we get your thickness T is equals to 4 lambda upon mu minus 1. Lambda has been given as 6000 angstrom, mu has been given as 1.5. Solving this, we will get your T is equals to 4.8 micrometer. We get thickness as 4.8. We are simply putting the value in this formula, that is T is equals to 4 lambda upon mu minus 1. Solving this, we will get your thickness as the thickness of the glass plate as 4.8 micrometer, which is your option 1, right? So the correct answer for question number 38 is option 1. Now coming to question number 39. Question number 39 says that in Young's double slit experiment, the intensity at a point where the path difference is lambda by 6. That is, they are saying that delta x is equals to lambda by 6 is I. Now, if I naught denotes the maximum intensity, then I upon I naught is. So, see, if delta x is equals to lambda by 5, lambda by 6, delta phi is equals to 2 pi by lambda into delta x. Putting this, we get phi or delta phi is equals to pi by 3. Pi by 3 or pi by 6? Yeah, pi by 3. We get phi is equals to pi by 3, right? Now the intensity, the maximum intensity or the intensity at any point will be given by the formula I is equals to I naught into cos square phi by 2, right? Phi by 2. From where I am using this formula? I am using this formula from the vectors. If that is, we have the resultant is equals to 2a cos theta by 2, right? So, or you can simply use directly the formula of I is equals to your I1 plus I2 plus 2 times of I1 I2 into cos phi, right? So we have your intensity as experiment, the intensity of the point path difference. This is I. So this is I, and this I is equals to I naught into cos square phi by 2. From this formula or from this formula, we will get your I is equals to I naught into cos square phi by 2. So phi is pi by 3. So we will put pi by 6 over here. So your pi by 6 means 30 degree. So cos 30 is equals to root 3 by 2. Because we have square over here, so it will become I is equals to I naught into 3 by 4. So I upon I naught is equals to 3 by 4. So the correct answer for question number 39 is 3 by 4, right? Using the basic formula which we have to use here is, that is I is equals to I1 plus I2 plus 2I1 I2 cos phi, right? 2I1 I2 cos phi. Now let's see question number 40. Question number 40 says that the amplitude ratio of two source produce reference is interference is 3:5. The ratio of the intensity of maximum and minimum. So if the ratio is 3:5 means A1 is equals to 3x and A2 is equals to 5x. So I max will be equals to your 3x plus 5x whole square, and I minimum will be equals to your 3x minus 5x whole square. So I maximum will be equals to your 8 is 64 x square, and your I minimum will be equals to 4x square. So I maximum upon I maximum upon I minimum will be equals to 64x square upon 4x square, which is equals to 16 upon 1. So the ratio will be equals to 16:1. So the correct answer for question number 40 is option 3. Right? Correct answer is option 3. Now coming to question number 41. Question number 41 says that in the Fraunhofer diffraction, at the angular position, the first diffraction minima, phase difference between wavelength in Fraunhofer diffraction, at the angular position of first diffraction minima, phase difference between the wavelets from opposite edge of the slits is. Now in Fraunhofer's experiment, for minima, delta x should be equals to n lambda, right? So because it's first minima, so delta x is equals to lambda. Phi is equals to del phi is equals to 2 pi by lambda into delta x. So your phi becomes 2 pi. The phase difference is equals to 2 pi. So the correct answer for this question number 41 is your option 3, that is 2 pi, right? Need to remember that in interference, the position of the bright fringe is equals to n lambda, or the path difference delta x is equals to n lambda. We need path difference as n lambda. But when it comes to diffraction, the same delta x is equals to 2n minus 1 into lambda by 2 for maxima, right? And for minima it becomes n lambda, right? It is opposite in diffraction and interference, we need to remember. Now let's come to question number 42. In question number 42, it says that if AB the incident wavefront, the refracted wavefront is. Now see this parallel beam of light is a plane having a plane wavefront. When passes through a convex lens, the light rays will converge, right? So it will have a converging spherical wavefront like this, as it has been shown in the figure, right? So this would be your option 2, right? So the correct answer for this question number 42 is option 2. We have already seen this and previous question. Now coming to question number 43. In question number 43, it says that in a Young's double slit experiment, if the source S is shifted by an angle phi as shown, the central bright fringe will be shifted by an angle phi towards. Now see, if the source is being shifted like this, then the path difference if you understand it like this, the path of the source S1 has to be traveled more in this direction, right? So the path difference will be 0 for both the waves, will be 0 at somewhere here, right? So initially the central maximum was here because here delta x was 0. But now this, the position where the delta x will be 0 will be here, right? Will be here. Therefore, the it will shift towards the end B of the screen, right? So the correct answer for question number 43 is your option 2, option 2, right? Not option 1, option 2, towards the end, right? Because if the source will be shifted here, see, if the source will be shifted here, what will happen? The path difference initially, see, if this was the scene, this was S1, this was S2, and this was S. Now the path was same. Now when S has come here, this and this light ray is traveling more path. Now if I want both the waves to reach the same with the same path difference, that is delta x is equals to 0, this light ray also will have to follow a larger path, and this path will be larger only when it comes towards B. If it moves towards A, again the path for this light ray will be greater, right? So it has to come to point B. Then only the path traveled by both the light rays, both the waves from S to the screen will be same, and then delta x will be equals to 0, and then we will get central maxima, right? This is the reason why the central maxima will shift towards the end B, right? So the correct answer for question number 43 is option B, option 2. Now let's see question number 44. The question number 44 says that in Young's double slit experiment, the fringe width is found to be 0.4 millimeter. That is, beta has been given to us as 0.4 millimeter, right? Now, if the whole apparatus is immersed in water of refractive index 4 by 3 without disturbing the geometrical arrangement, the new fringe width will be, can be given as, see, beta is equals to lambda d by d. Now, when the whole arrangement is immersed in a liquid of refractive index 4 by 3, the wavelength will change. How wavelength will change? New wavelength lambda dash will be equals to lambda upon mu, right? Lambda upon mu. So your new lambda dash will be equals to lambda upon mu is given as 4 by 3, so 4 and 3 will come to here, the numerator, so it becomes 3 lambda by 4. So if initially beta was equals to lambda d by d, now new beta dash is equals to 3 by 4 times of lambda d by d, and lambda d by d is nothing but beta. So new beta or new fringe width beta dash is equals to 3 by 4 times of beta, and beta has been given to us as 4 millimeters. So beta dash will be equals to 0.3 millimeter, right? So we have 3 millimeters in our answer. Yes, we have 3 millimeters. That is option 4. So the correct answer for this question is option 4. The relation which we have used here is that beta is directly proportional to lambda, and lambda is inversely proportional to refractive index, right? So using these two relations, we get the new fringe width is equals to 0.3 millimeters. Coming to question number 45. Yeah, question number 45 says that what is the angular width between the central maxima and the first order minima of diffraction pattern due to the single slit of width 0.25 millimeter when light of wavelength 600 nanometer incident on it normally, right? Now, if angle is very less, then sine theta is taken approximately equals to theta, right? Now for maxima, we know that a sin theta is equals to 2n plus 1 lambda by 2 is the formula, right? So here we have the first maxima, putting n is equals to 1, we get a theta is equals to 2 lambda, sorry, 3 lambda by 2, 3 lambda by 2. We have the value of lambda and we have the value of a. So if we have a theta is equals to 3 lambda by 2, we need to calculate theta. So theta will be equals to 3 lambda by 2a. In the question we have given as lambda is equals to 3 nanometers and a is equals to 0.25 millimeters. Putting the values with the correct units and solving it, we get theta is equals to 3.6 into 10 to the power of minus 3 radian, right? So the correct answer is option 1 for question number 45. Coming to question number 46. Yep. Question 46 says that in Young's double slit experiment, the ratio of the path difference corresponding to the third maxima obtained in air to the third minima obtained in water is. So the third maxima in the air, the path difference is given by path difference for third maxima is equals to 3 lambda, right? Then the path for the third minima in water will be equals to your C, that is 2n, using the formula 2n minus 1 into lambda by 2, putting n is equals to 3, we will get 5 by 2 lambda, right? Here the value of lambda will be equals to, not be placed at lambda, it will be placed at lambda upon mu, which will be equals to 3 lambda by 4, right? 3 lambda by 4. So we have, from here we'll get your position of the minima in water, third minima in water will be equals to 5 by 2 into 3 by 4 lambda. So we'll get 15 upon 8 lambda, right? So they want the ratio of this 15 upon 8 lambda to your 3 lambda. So 15 upon 8 lambda, 3 lambda upon 15 lambda upon 8. So multiply with 8. This will give you 24 upon 15, which is equals to 8 upon 5, right? So the correct answer is option number 4, right? Again, for the path difference, delta x for third maxima will be equals to 3 lambda delta x. This is in air. Now in air itself, delta x for third minima will be equals to 5 by 2 lambda. But when it is in water, this lambda will be replaced by new lambda, that is 3 by 4 lambda. So delta x in water for third minima will become 15 lambda upon 8. So we have to find the ratio between this path difference and this path difference. Finding the ratio, we get the ratio as 8 by 5. So the correct answer for question number 46 is option 4. Now coming to question number 47. In Young's double slit experiment, the slit is separated by 0.2 millimeters. This is small d given to us. The screen is placed at 1 meter away. Capital D has been given to us. The distance between the central bright fringe and the fourth bright fringe is measured to be 1.5 centimeter. Means 4 fringes. That is 4 beta is been given to us as 1.5. Right? 4 beta is being given to as 1.5 centimeter. The wavelength of the light is, the wavelength of the light is, the wavelength of the light means we have your beta is equals to lambda d by d, right? And here there are 4 fringes, so it will become 4 and this beta is equals to 1.5 is equals to 4 into lambda we don't know into d is been given to us as 1 upon small d is been given to us as 0.2 into 10 to the power of minus 3. Question number 47, right? So that is lambda will be equals to 1.5 upon 4 into 0.2 into 10 to the power of minus 3, right? Solving this, you will get lambda is equals to 7500 angstrom, right? So the correct answer, this is 1.5 centimeter, na? Centimeter will convert into meter, it is 10 to the power of minus 2. This is again in meters, right? Now the solving this will get your wavelength is equals to, let me check, not 7500, it's become 1.5, this and this will make it 10 to the power of minus 4, 10 to the power of minus 4, 1, 2 is equals to 7.5. So 7.5, 7.5 into 10 to the power of minus 7. Yes, 7500 angstrom. So the correct answer is 7500 angstrom. The correct answer is option 3. Option 3 is the correct option. Answer for question number 47. Now let's see question number 48. Question number 48 says that a transparent material has a refractive index is equals to root 3. The incident angle of unpolarized light at which the reflected ray will get completely polarized. So that will be that IP, and IP is equals to tan inverse mu, and mu has been given as root 3. So tan inverse root 3. Tan inverse root 3 means theta is equals to 60 degrees. So the correct answer for question number 48 is 60 degrees, that is option 2. Right? Formula uses tan IP is equals to mu. Mu has been given as root 3, so IP is equals to 60. Right? Question number 49. Question number 49 says that two identical coherent sources are placed on a diameter of a circle of radius r at separation x, which is much less than r, right? Symmetrically about the center of the circle. The source emits identical wavelengths each. Okay. Now the number of points on the circle for maximum intensity is where x is equals to 5 lambda. So x is equals to 5 lambda. So if we check on the points, this point and a point opposite to this, for both the cases, the path difference will be 0. So here we will have maxima. Path difference, that is delta x is equals to 0. Now if we check at this end, here the delta x will be equals to 5 lambda. Delta x will be equals to 5 lambda. Why? Because this ray will travel only this much of path, and this ray will travel this path, and this path, the path difference will be equals to 5 lambda, which is equals to x. So here it is 5 lambda. It means while moving from this point to this point, that is while moving in 1/4, there is a path difference of 5 lambda. It means there will be 4 points here, that is 4 point here, where it will have a path difference of 1 lambda, then 2 lambda, then 3 lambda, then 4 lambda, and finally it comes to 5 lambda. So in 1/4 it is having what, 5, having 5 maximas. So we have 4 quarters here, so therefore 5 into 4 is 20 maxima. So the correct answer for question number 49 is your option 1. I hope you understood. Again, if I draw a bigger circle, uh, bigger circle, here at this point delta x is equals to 0, and here delta x will be equals to 0 is equals to 5 lambda, right? 5 lambda. Why 5 lambda? Because the distance between the two slits here is 5 lambda. So this light will travel, let's say, y distance. So this light will travel y plus 5 lambda. So path difference will be equals to 5 lambda. Now if the light waves from moving from this point to this point having a path difference of 5 lambda, definitely at this point it would have a path difference of lambda, then it would increase to 2 lambda, then it would increase to 3 lambda, then it would increase to 4 lambda, and then finally to 5 lambda. It means at all these points 1, 2, 3, 4, 5, 6, all the 6 points there will be maxima. So within this quarter we have 4 maxima, again 4 maxima, again 4 maxima. Similarly we have 4 maxima. So 4 are 16, then 1 17, 18, 19 and 20. All together we will have 20 maximas over here. So the correct answer will be option 1, right? Now coming to question number 50. Question number 50 says that in Young's double slit experiment shown in the figure, S1 and S2 are coherent sources and S is the source having a hole at a point of 1 millimeter, right, away from the central line. The light 400 to 700 nanometer is sent through the slit. Which wavelength passes through the hole has a stronger intensity, right? So in the question they say that in the Young's double slit experiment shown in the figure, S1 and S2 are coherent sources and S is the screen having a hole. This S screen is having a hole here, right? The screen is having a hole at a point of 1 millimeter from the central line. From this central line, this distance is equals to 1 millimeter, right? This distance is equals to 1 millimeter. Now the wavelength, white light, that is white light is from 400 to 700 nanometer, the wavelength has been given to you, is sent through the slits. Which wavelength passes through the hole has stronger intensity? Means when the white light has been used for Young's double slit experiment, at center it has a bright white fringe. Then according to the wavelength, different lights have their different maxima at different positions, right? So what they're asking is which color light is having its maxima at this point, right? So at this point, what is the position? Position is your beta is equals to your 1 millimeters, right? 1 millimeter. Now delta x is being given to as n lambda d by t. So lambda is equals to, from here we can say that lambda is equals to delta x d by nd, right? Now putting this value, we are putting n as 1 and lambda, we get your delta x is equals to 1 millimeter. So 1 into 10 to the power of minus 3. Small d is your, that is the distance between the slits, is being given to us as 0.5 into 10 to the power of minus 3 upon n into lambda, that is n into capital D, that is 550 50 centimeters, right? 50 centimeters. So we will have this C, lambda is equals to delta x. Delta x has been given to us as 1 millimeter, so 1 into 10 to the power of minus 3, right? Now into small d has been given to us as 0.5 millimeters. So we will write it as 0.5 into 10 to the power of minus 3 upon n into capital D is being given as 50 centimeters. We will write it as 0.5. Solving this, we get lambda is equals to 1000 nanometer upon n. So for n is equals to 1, lambda will be equals to 1000 nanometer, which is not in the range. For n is equals to 2, lambda will be equals to your 500 nanometer, right? So the second bright fringe, for the second bright fringe of light wavelength 500 nanometer will have its maximum intensity, that is maxima, at this point where there is a hole in the screen, right? So the correct answer for this question number 50 is option 3, that is the light of wavelength 500 nanometer will find its maxima at the point where the hole is being made in the screen, right? So here we end up with all 50 questions of your BPD 70. I hope you understood the questions and the solutions. If you still have any doubt, you can drop it in the comment box of the video, right? And you will be held accordingly. So I hope the explanations are clear to all. This is all from my side. Thank you.